not even really fall right now. It's just early winter. At least it doesn't feel like fall until like the afternoon when the sun sets its peak. Sorry. That's not supposed to happen. It's almost like I'm not using this equipment for its intended purpose. Stay. Good dog. All right. Mouse cursor somewhere. Welcome back. I hope that nice breaks were had by all. Wherever your break took you, I hope that there was some nice rest and potentially some good food. Let's see. Today is Monday, November 29th, and this kicks off the last full week of classes for the semester. The main thing to note about this particular week is we are going to be having test 2 on WebAssign this week. As a reminder, once the test goes live, I'm going to post it this afternoon. It'll be open until midnight on Friday, and you can take it at any point in time this week, whenever you want to, whenever you feel ready and comfortable for it. And just because it takes longer for you to be able to get answers and feedback from me, the timer will last 5 hours, even though the test is designed to take you under 1 hour. And again, I'm going to repeat myself constantly. So, no lab this week to make up for kind of that loss of time. So no lab, you do not have to come to lab. Instead, you can use that time for studying or for taking the test itself. And what I will be doing in the afternoons is I will be in this classroom for at least a little while in case someone wants to take the test in the room with me, or in case you just want to study and have questions, and I can go over stuff on the board with you. So lab times are now optionally study sessions, if you want to come in for those. The main exception to that is I won't be here during normal lab time tomorrow. It will just be Monday, Wednesday, Friday that I'll be here in the afternoons. But across the board, no lab. Additionally, tonight, the Chapter 8 homework and quiz review. We had covered everything by Monday. I just decided to leave it open until now in case someone wanted to spend the extra time on it. They're officially due tonight, so if anyone has questions about those, the floor can open up for those in a minute. I keep losing my train of thought. It is very much a Monday. And what we'll be spending the bulk of this week proper doing is studying, going over any questions you guys have about test stuff, going over any and all review things needed for the upcoming exam. As a reminder, the 3 exam times are over here. I don't care which one you attend, you can swap between them as long as I know about it in advance. And like how I post test prep questions and resources, I will also be posting exam prep questions and resources that we can go through this week as well. And lecture this week will mostly just be prep work. I might also give kind of some miniature lectures on a few additional topics, because normally when there isn't a quarantine level event that's causing us to massively reschedule things, this class does like to go over things like pressure and sound, and I do find those to be useful pieces of information to a human to experience life on Earth. So if we have some free time during class when no one has questions, I might do some mini lectures just on some concepts that I think will enrich your life on Earth experience. So that's this week. Any questions or needs about anything that I just mentioned? Okay. In a minute, I'll open up the floor to any questions related to the Chapter 8 assignments due tonight or to studying for the test this week. I might also show you the test prep stuff that I have on Brightspace. Excuse me. Real quickly though, just very, very small announcement. I think I sent out an email advertising this advertisement is only the people taking 1510 next semester. If you're not taking 1510 next semester, you can zone out right now. I believe I sent out an email telling you guys that a second lab section opened up for 1510 next semester. We're currently in an interesting situation where the old section is full and the new section is about half full, and we're getting reports from people who need to get into the Thursday section because they can't fit the Wednesday section. So I just ask you guys, if you can do the Wednesday section, if Thursday is not a requirement for you, we're just asking people to switch over so that everything hopefully equalizes and everyone can get what they need. So, small request. Sorry to bug you about it. That said, main articles for this week are the homework due tonight and the test 2, and then prepping for the exam. So, starting with the homework that's due tonight, what questions, if any, would you guys like to go over?
I forgot what number it is, but it's the one about the space station and like the 150 people. Things like number.
Yes, that is question 3.
3.
And I have made that a bonus question because it broke my limit of if I can't do it easily in 2 minutes, it's not fair to you guys. But some people had already finished it and I didn't want to penalize them by removing it, so it's a bonus question. And I'll fix everyone's grades after the time. Any other Chapter 8 homework related inquiries at this time? If you have any questions about that, please let me know at absolutely any time. Let's now look briefly at Brightspace, which asks to sign in every time I need it. Let's tab down to the new Test 2 tab. If you click on the tab itself, we provide a list of the concepts from Chapter 6 through 8 that will be on the WebAssign test this week. It'll be roughly about 8 questions, and I expect 3 of them to be concept-based, bless you, rather than math-based. And as a reminder, since WebAssign won't grade the concept questions correctly, I will be grading all of them myself. But I can write my own WebAssign questions. This is the list of everything from Chapter 6 through 8 that will be on Test 2. Main articles to be aware of are momentum and impulse, which is defined as change in momentum. From there, we also use those principles in collisions. And because collisions also reincorporate elements of kinetic energy, so keep that in mind as well. I'll go back after this list. Actually, edit. Okay. Momentum, impulse, kinetic energy. Because kinetic energy is utilized in collisions, namely that kinetic energy is conserved in elastic collisions and not conserved in inelastic collisions. Meanwhile, momentum is conserved in all types of collisions. So, be able to recognize what types of questions are collision questions, how to start them. There's 3 starting points depending on what type of collision it is. And that's all Chapter 6. Moving on, chapters 7 and 8 was all the angular stuff summarized in this table here. Chapter 7, we began by talking about rotational movement, namely the angular counterparts to displacement, velocity, and acceleration. Converting between them, utilizing the angular versions of old formulas, etc., etc. We also incorporated centripetal acceleration, which is kind of a halfway point between linear and angular, so it's not really on this chart. And we incorporated the universal law of gravitation because it commonly acts as a centripetal force. These three items represent chapter 7. Scrolling down, moment of inertia and rotational statics and dynamics represents chapter 8. Moment of inertia is the angular counterpart to mass. All objects have their own depending on their shape and how they're rotating. There will be charts available to help with that at all times. And statics and dynamics encompasses torque, rotational kinetic energy, and angular momentum, the angular counterparts to other linear concepts, which all work pretty much the same way. For torque, for static torque examples, recall that all the torques on an object must add up to 0 for an object to remain stationary. So you'll probably have to balance some torques. If the torques are not balanced and they don't add up to 0, then you get rotation, and torque will equal moment of inertia times angular acceleration. And kinetic energy and momentum work very similar to their linear counterparts. That is everything that will be on this particular test. It's primarily momentum collisions and then all the rotation stuff. A lot of these concepts do build on some of the older ones. So, for example, between regular kinetic energy and angular kinetic energy, there is some energy-related things to remember. Force is going to be a constant throughout the entire class, but this is the primary list of things to focus on. If you look at these and you read a concept and you are not immediately confused as to what that means, you'll be fine. Additionally, in the Test 2 tab, there is also practice questions. The practice document is in here twice, once as a Word file and once as a PDF. Sorry to Mac users, but I literally can't create a Pages file on this machine. I don't know how. So that's just up here in 2 different formats, depending on which version you want to use. I encourage you to look over it. If you can do these questions, then you will be absolutely fine for the test, because I make these guides longer and harder than I make the test. It's better for you to struggle with the practice than with the test itself. We can absolutely look at those questions here if you want to. I also have gone ahead and put up a practice key. Both of these were up a week ago, but I don't know if I showed them to you in class. And the key has answers to the concept questions and all the math. If you at any point have a hard time deciphering my chicken scratch handwriting, please let me know. So these are all good test prep resources. Similarly, they will be useful for exam prep as well, because the exam will just be all of chapters 1 through 8. I will be posting additional exam practice questions in the same vein as these, just if you want additional practice. Those will be up hopefully by the end of this week, guaranteed by next Monday at the very latest. And like I said, we can continue practicing together in class. How do you guys feel? Mostly nodding my way. As you're studying, please let me know any questions that you have. While we're here right now, are there any test 2 concepts or specifically test 2 practice questions that you'd like to go over? Yes.
It's not test 2, but I did figure out the other homework question.
Okay. Sorry, which one?
5.
5, yes. My ears don't work so good, and I apologize for that. millstone, used for grinding grain in a grist mill. For those who've never seen such a thing, it's literally a round rock. It's, whenever you like see a cartoon or a movie that references like the invention of the wheel, it's a big stone wheel. It's round. So, solid cylindrical wheel that can rotate about its central axle with negligible friction. So, that is hinting at, let's see if I can use this table in the homework. That is hinting that this is the shape that we're looking at. Some round, solid, cylindrical, technically object rotating about its center. That shape tells us that if we need it, we can use this formula for its moment of inertia. We know the wheel's radius, and there is a force of 300 newtons applied to the edge of this particular rock. That force causes it to angularly accelerate at some rate that will vary depending on your version of the question. First thing you're asked is, what is the moment of inertia of the wheel? And I think, yes, good. My labels here might be a little bit off, but these should be all the formulas that you would need for number 5. First, what is the moment of inertia of this particular object? It is functionally a solid cylinder. It's just more, not as tall as it is wide. We know its mass, we know its radius. Since we know what shape it is, on our table, if we look up solid cylinder rotating to the center, this is the formula for moment of inertia to use, specifically half times mass times radius squared. Oh wait. Oops. My bad. There is a reason I listed them in this order. Okay. This is the formula. We will need it for part B, not for part A. My apologies. It's failed. So since we don't know the mass of the wheel, we do kind of have to get to that information backwards. We have to figure out moment of inertia through some other means first. And if we look at what's physically going to happen in this situation is this big stone wheel, there's some force pushing on its edge, just forward tangent to it, and we know that if this force is being applied at a radius away from the fulcrum, it's going to make it start spinning. So this force will generate torque, and that torque, so force at radius creates torque, that torque will create an angular acceleration based on this specific object's moment of inertia. So for part A, since we don't know mass and can't find moment of inertia using this formula yet, I recommend combining these two formulas. We know every wheel will have the same radius and a known amount of force, so you can calculate the torque present on the wheel. You're also told its angular acceleration, so if we set the two torques equal to each other, the only unknown left is I. So in part A, we can find I using this method. In part B, once you know I, and I do recommend completing part A first, making sure your answer is correct. Once your answer is correct, you can pop I. You can put your answer for I into the formula for the moment of inertia of that wheel. You would find I in part A, you would know R from the question, you can solve for M. Part C, wheel starts from rest and accelerates over a period of 4 seconds. What is the angular speed of the wheel at the end of this time period? So part C is just an angular acceleration question. I recommend utilizing angular Fantastic Four Formula 2. We know this wheel is angularly accelerating, and we know some amount of time that it will be accelerating. If it starts from rest, we can figure out its final velocity as a result of that. How's this one feel? Okay. Anyone else? you can. Feel good about 5 for right now? All right. 7. I forgot which one that was. Okay. We have a merry-go-round, and we are told the weight of this merry-go-round is a large, heavy object. This is its weight, the force of gravity, not its mass, but its weight. And this particular merry-go-round has a known radius, and it starts from rest. So it's initially not moving, and then a force is exerted upon it. This force is tangent to the circle of the merry-go-round. That means it's going to be perpendicular to the radius. It's going to create a torque. So same picture as the wheel over there. So this force is being exerted with the goal of making the merry-go-round spin. We've been asked to find the kinetic energy of the merry-go-round after 5 seconds. We're told the merry-go-round can be assumed as a solid cylinder, and that the relevant force is applied at its edge, and the picture will look the same as number 5. So, is that its weight? Oh. Phys1500 did a little bit of a tricky thing. It gave us the weight of the merry-go-round, even though what we actually need is the mass of the merry-go-round. Okay, let me back up. What we've been asked for is the kinetic energy of the merry-go-round after 5 seconds. So we want, very specifically, angular kinetic energy. Merry-go-rounds tend to remain in place, but they still need angular kinetic energy while they're spinning. So our goal is angular kinetic energy. Look up our formula for angular kinetic energy. We only really have one. That's 1/2 times moment of inertia times angular velocity squared. So we want angular kinetic energy. And to get there, we need 2 things that we don't technically have yet. So our first steps are to find the moment of inertia and to find angular velocity at the specific point in time we've been asked for. Everyone's time, I think, will be different, because the time is a red number. For me, it's after 5 seconds. This will become relevant in a second. We've been given time, we've been given weight. And radius. Your numbers will vary, but these are all good pieces of information to know. So we need to eventually get moment of inertia and angular velocity to find the kinetic energy in question. So we need some method of determining those. We have been told what shape we can treat the merry-go-round as. A solid cylinder, so actually the same shape as the wheel. This will probably be the most common shape we actually end up using, frankly, because most wheels are technically this shape. And that means we can use the same formula for moment of inertia. 1/2 times mass times radius squared. We already know the radius. We technically don't know mass, but we can find it, because whatever the wheel's merry-go-round's weight is, we can reverse engineer the mass from that number. So whatever that weight is, remind ourselves that Fg will equal mass times 9.8. We're going to need to figure out mass from that, plug it into this formula to find the I that we want. So that's the route I recommend to find the I that we need to get to our final answer, which might become even more important in a second. We also need angular velocity. We need to know how fast this wheel is specifically spinning at whatever moment in time you've been asked about. And there's several different ways that one can calculate angular velocity like that. I'm going to go ahead and recommend Fantastic Four formula 2. Again, it's the one with the least amount of terms. We know that the merry-go-round will be accelerating. There's a force applied to it, there's a torque. The whole point of that is to get it spinning in the first place. So there's some angular acceleration, and after, for me it's 5 seconds, the time will vary, its velocity will increase to something. So our next step is actually to figure out angular acceleration. And that will get us the omega we're after. Which means we need to figure out angular acceleration somehow. And where that acceleration is coming from is the torque that's making it spin up from rest. There's specifically a force applied at its radius, and that's going to be what makes it spin. Actually, these are the two formulas that I draw your attention to. We know there's some amount of torque, which is a force acting at its radius, and it's going to angularly accelerate as a result of that torque. So the way to find angular acceleration that I would recommend is actually the same approach as 5a, although we're solving for a different thing. Set the two torque formulas equal to one another. So it's a good thing that we already talked about how to find I, because you need that number again. This little flow chart became a little more complicated than I initially realized. Sorry for all the moving parts here, pun not intended. So I guess my general recommendation for getting the eventual kinetic energy that we're after, we need to know I, to figure that out, calculate mass, mass times radius squared. That will go into our kinetic energy formula, but it will also be used to help figure out angular acceleration, which we will use to figure out the final angular velocity, which will also go back into the kinetic energy formula. A lot of moving parts on this one. How's this one feel? It's okay if it feels weird. I would like to know about it though.
I feel like you have to do a lot of steps to get to the final.
There is, which is probably why it's the only part of this question.
Yeah.
I suppose what I like to do on test questions, if there's a lot of things that you have to find to get to the answer, I tend to, like if I was writing this, I'd probably make it a multi-parter, and each of the steps would be finding each of these things. That's how I tend to write the questions. Like I'd probably ask you first, what's the moment of inertia, what's the angular acceleration, da 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 da. So that's one issue that I have of the sign personally, and that's why again I'm handwriting and curating the test questions myself. I'm glad you asked. Again, a lot of steps. I apologize for that. Question?
Okay, can you go over the short answers on the test 2 practice?
Sure.
Because number 1, I'm a bit.
Okay. So we're looking at test 2 practice questions now. Question 1, explain the difference between centrifugal and centripetal forces. Let's start with centripetal force, because that's actually a real thing that we measure and use in our math. Centripetal force is the center-seeking force, that is what, in an orbital motion, is the force pulling the object towards the center of its orbit. For the case, I'm running on a board again. I'm repurposing this wheel drawing. What I'm pointing to won't be a wheel, it's going to be an orbit. I'm just reusing the circle. Let's go with the Earth and the Moon. So, the real world force that actually exists, there's more examples than just this. The centripetal force is some real force that pulls an object towards the center of its orbit, and that's the force that keeps it moving in a circle even as its momentum tries to make it move forwards instead. So gravity keeps the moon moving in a circle around the Earth. If you're turning a car, friction on the car is what pulls you towards the center of your motion. If you're swinging a rope around, it's tension in the rope that's doing that. Some real thing acts as the centripetal force every single time. It's a real force that actually really pulls on things. It's pulling you towards the center of the circle. And this definition is actually where the word centripetal comes from. The root word centri means center, and the word petal means seeking. So it's the center-seeking force. This is contrasted to almost said the wrong word, centrifugal force, which there isn't a formula for. We don't do math for it, because there isn't an actual force acting on you that you perceive. Well, no. You perceive something that we call centrifugal force, but there's not actually a force pulling on you in that way, which is why some people call centrifugal force the fictional force. So the short answer is it's not a real force. You feel it, but what you're feeling isn't technically a force pulling you out of the circle. Whereas centripetal is center-seeking, fugal means fleeing. So centrifugal force is the center-fleeing force. Whenever you're turning left in a car, this is the force that you feel that makes it feel like you're being pulled to the right, out of the circle, out of your car. So if instead of moon around Earth, this was a car doing donuts around some central post, if you were physically in the car, you might feel like you were being pulled away from the center as the car turns and you're lurching to the right as the car is turning left, or you're lurching to the left as the car is turning right. The thing is, there's not actually a force pulling you out of the circle. What kind of feels like it's pulling you out of the circle is your own body's tendency to keep moving forwards. So you're not actually being pulled rightwards. Your body, without any force input, just wants to keep moving in a straight line. So your body moves forwards. If we're using the car example, your seatbelt, meanwhile, pulls you to the left with your car. So the same centripetal force acts on you via the seatbelt. But what you're feeling is your body wants to go forward, your blood cells want to go forwards. And the force that you feel is actually the force your blood cells exert on the outer edge of your body, your skin, your arteries, insert biology term here. And therefore your skin, your blood cells, your arteries, etc., exert an inward force on them to keep them in your body. So what you feel is the sensation of you being yanked to the left while your limbs and blood are trying to go forwards, not actually to the right. The reason that this is a real phenomenon, so when I call it fictional, I'm not saying that it's all in your head, you're not making it up. You do feel this, it's just not a force. It's just your own tendency to want to move forwards. Yes?
So then the second part of that answer should say centrifugal force.
Oh!
That's why I was so confused.
Thank you for pointing that out. I'm a human that makes mistakes sometimes. So, I didn't even notice that. I spent 5 minutes explaining this, and the problem was a typo.
Yeah.
Oh, I'm sorry. I am so sorry. Yes, this is supposed to say centrifugal force isn't due to any actual force, it is a sensation due to your inertia. That's the key difference there. Wow, my apologies. So, centrifugal force is the fake one. Centripetal force, some real thing acts as it, and it does pull you towards the center. I need to fix that somehow. Boy. Okay. I need to fix that. I need to leave a note to myself to do that. Sorry. Does that help?
Mm-hmm.
Okay. Well, I'm upset at myself now. That's okay. That's to be human. Sorry again. Oh yeah. All right. I will fix that typo. What else? What else is on your minds? It is okay if you don't have any questions at this immediate time, because I know I certainly don't usually know what I don't know until I'm in the moment studying. We're nearing the end of official lecture time today. I actually want to make one more announcement that I forgot about at the beginning. My apologies. I've mentioned this to a few people already. I don't think I've actually mentioned it as a formal announcement yet. I apologize. We're nearing the end of the semester. First of all, congratulations. Second of all, it's been great teaching you guys. Third of all, some people have missed labs. It's unavoidable. Sometimes you're sick and just can't make it up in time. Sometimes you just, any reason, some people miss labs. That's okay. But obviously, we want you to have a grade for that slot so that you don't get a 0. So, if you've missed a lab at any point in the semester and didn't make it up, then I am offering a makeup lab. It's going to kind of just be a take-home assignment because we're not meeting for a lab this week. So think of it as just an extra homework assignment in place of the lab that you missed. And I'm going to be posting it to Brightspace. I'll probably email it out as well so that it's in your inbox and you don't miss it. This is only if you missed a lab. If you attended all of them, then don't worry. If you think you might have missed one, but you're not sure, you just don't remember, email me and I'll let you know. It'll just be a makeup assignment. It's kind of an independent short answer research type thing where you'll maybe use a simulator or look into a specific concept and come back to me with your results. It's basically just an extra homework, but it's just a take-home lab assignment to make up for anything you might have missed. Again, if you didn't miss a lab, you don't have to do this. This is just for people who did and need the extra slot taken up by a grade. If you missed one and don't make it up, then it will go in as a 0. I'll let you know what your grades are and what we can do about that. So if you missed one, do please spend some time with the makeup assignment during this week. But since there's also a test this week to study for, the makeup assignment will be due next Monday. So if you missed a lab, you'll have this extra thing that you can work on. No rush. Work on it on your own time, your own pace, and that'll be due Monday. Test will be open until midnight on Friday. This is so that I can grade it over the weekend so that everyone has their scores and their feedback. And then on Monday, we will, bless you, I'll collect any, forgot how to speak English for a second there. On Monday, I'll collect makeup assignments. We'll talk about the exam, we'll prep, we'll have a good time. I like to make Christmas fudge. At some point this week, we do have to, well, I'll let you know. Sorry, no. That was a vague statement and I don't want to scare anybody. You remember that inventory, short 30-minute, no credit against you inventory thing we did at the start of the semester? We sat down for 30 minutes and just answered multiple choice questions and that was it. We have to do the end of semester version of that at some point, just to gauge growth. The department knows where everyone is exiting the course, so that we do things better, know exactly what was effective, what was something to improve on. So at some point this week, we're probably going to be doing that during class, just to make you aware of it. So a couple of things we'll be working on in lecture this week. We'll do that at some point. We'll go over test and exam stuff, and I'll probably talk about, maybe just spend 10 minutes talking about pressure and sound, because I like to talk about those things. If no one has questions, I need to talk about something. So, we're nearing the end, don't want to hold you up on a Monday back. Break, got a question or stretch.
How invasive is the final exam? Like,
How-
is it gonna be, well.
Or the
is
word
it-
used was invasive.
No, how many problems are there?
Good question.
How invasive? Sorry.
So it is designed to test you on stuff from the whole semester. I would expect it, if I shorten each test down to about 7, 8 questions, I'd expect the exam to be about 15, 16 questions, of which maybe a third will be concept. So it's not just going to be an entire 3 hours and a half. Since we're locked to a 3-hour time slot, I'm going to make it designed to last an hour and a half, and then you'll have the extra time for other academic accommodations or just to fine tune things. I'd expect around 15, 16 questions.
Okay.
Very similar to test, just longer. If you have any questions, please feel free to stick around and ask. If not, send me any when you have them. Again, I'll be in here around lab time if you want to come in for questions or you want to take the test in here. I'll see you around. Over here. Gravity's blue today. Thank you.